Sorry about the last video. With the last video, my iPad died, so sorry that we kind of like stopped in between a math problem. But now we're all charged up and ready to go. So let's go back from where we started, or where we left off. We left off on slide number 17. We were working on finding the maximum kinetic energy of the emitted electrons, and we found the energy, we found the work function, or we were given the work function, we just had to convert it into a different unit. The only thing that we have left is to try to solve for Kmax. So that's where we were at, so let's start there. So I have that my energy is equal to Kmax plus the work function. We knew our work function, we calculated our energy, we're trying to solve for Kmax. So this is E equals my Kmax plus this number. So how do I get Kmax by itself? To do that, I need to subtract the work function from both sides. So I'm going to subtract from both sides that 3.2 times 10 to the negative 19th. Okay, when I do that, I'll be left with my Kmax. So guys, when you subtract them, you should be left with a 4.2 times 10 to the negative 20th joules, and then that'll be your answer. So 4.2 times 10 to the negative 20th joules, and that's your Kmax. So we're done with A. We have A now. Now what they've asked us to do in part B is to find the maximum speed. Okay, now let's think about this. We're trying to solve for velocity. We know kinetic energy. So then that should automatically make you think of the formula for kinetic energy, which is 1/2 mv squared. Okay? I know that K equals 1/2 mv squared. I know K because we just solved for it. It's 4.2 times 10 to the negative 20th joules. Now, do I know the mass? And I'm trying to find velocity. So the only thing that I don't really know is the mass. But you really do know it because light, or these photons, are created because of electrons. So I know the mass of the electron because they give me that in the front of my AP test. Or they give me that in the book. That's like, I think it's in the back of your book. But the mass of an electron is 9.11 times 10 to the negative 31st kilograms. Okay, so then that means I have everything I need to find V. That's my kinetic energy. Here's my 1/2, that's my mass, and that's just the mass of an electron. I'm trying to solve for V. Okay, so now let's do some math here. It'd just be easier if I took half of the mass of the electron, so I take half of 9.11 times 10 to the negative 31st. To get V squared by itself, I'm going to have to divide that, and then square root. When I do all the math, when you do all of the math, you should get your velocity to be equal to 3.04 times 10 to the 5th meters per second. So that's what I get for my velocity. Okay. Now, the last part is part C, and in part C, they want us to calculate the stopping potential. The stopping potential is that V0. So one of the equations that we know for that is Kmax equals E times VO. So in part C, Kmax equals E times VO. Well, we know our Kmax. We've used that in the last two problems. So Kmax is going to be 4.2 times 10 to the negative 20th equals, my E, like we said, is just the charge of the electron. And I can find that where? I can find that on the in the front of the test book, or you can find that in your actual textbook, in the back of your textbook. So I know that E just stands for the charge of the electron, and that's 1.6 times 10 to the negative 19th. And then that E will be times VO. So here's my kinetic energy, there's my E, I'm trying to solve for this. So how am I going to get this by itself? I'm going to divide both sides by this number to get VO by itself.